Yes, I'm from International Water Management Institute. Actually, our headquarters is based in Sri Lanka, but we have several offices in India. I'm based in Hyderabad, and we have our regional office in Laos, Southeast Asia regional office, and in offices in other countries, Africa, Central Asia, Nepal, and Pakistan. So we are mainly looking at water management issues. And this particular, actually we are not really working on milk per se, but we are really looking at how best we can manage water so that we can have a big impact on different sectors. Well, in this particular talk, I was asked to talk about water footprints. So of course, I have to start talking about what it is. So I will show you what are the water footprints, what do we hear these days about it, and why milk water footprints, why it is so important. And then with some examples, I will show you, some problems we have and some solutions that we can have for sustainable milk production. Well, of course, you have seen these numbers. 1,000 liters per 1 liter of milk, 1,800 liters per 1 kg of wheat, 2,005 liters per 1 kg of rice. This is the kind of water requirement or the water depletion when producing different products. And in case of beef, it's about 15,000, more than 15,000 liters per 1 kg of beef. So of course, these numbers are hugely different. But it doesn't really, you have to put them in the context. Otherwise, it doesn't really make any sense. Now, sometimes we have these big numbers, and then we talk about what are the water use, basically water depletion with respect to for 1,000 kilocalories, so producing 1,000 kilocalories of consumption. And you can see in the second column, those are the numbers. It ranges from 589 in the wheat, to about 8,800 in the beef. And for milk, it's about 1,400. At the same time, we talk about water footprints for daily consumption. Now, I have given you some numbers based on the previous, water footprints of previous slides, and estimated it for Asia, South Asia, India. And you can see clearly it also depends on different diets. And for instance, India, the cereal consumption is about a little bit over 400 grams per day. And if you divide it into rice and wheat, it is about 468 cubic meters per whatever the consumption. And then wheat is the next one. And for milk, it's about 119 cubic meters per, I think should be liter, per the amount consumed per daily consumption. And for beef, it is the smallest, because Indian diet has a very small amount of animal products consumption except beef, except milk. So there are varying figures of water footprints. It depends on one country to another, depending on diets. It depending on one product to another, based on the intensity of water requirement, water required to produce that. So what is it? What is milk water? What is water required for milk and in beef? Where does it come from? That's exactly what we need to look at. So I don't want to go through all this, the theory, but what I want to tell you here is it's not a new thing. water footprints are basically the reciprocal of water productivity that everybody have seen sometime or another. And in fact, it's based on water production functions. Those are age-old concepts. And we define water productivity based on water production function. So if the production is not only water, it depends on so many other factors, but control for other factors. And if you take the water production function, water productivity is basically the production divided by the water consumed. And that is, in this particular first graph, it is basically AP, or the ratio of AP, that is the production over the water consumption. That's in the horizontal line. And water footprint is basically the reciprocal of that. So instead of talking about kg for cubic meters, we talk about cubic meters per kg. So total water footprints is nothing but the opposite of, or the reciprocal of, water footprints. And if you are talking about maximizing water productivity, then we are basically talking about minimizing water footprints. And where it happens is a different issue, but whether we can maximize water productivity or minimize water productivity, more water footprints, these are different issues. But the idea is that if you want to maximize, increase water, if you increase water productivity, certainly you decrease the water footprints. Now there are several components to water footprints. And this was basically concept defined by Dr. Arjun Hoekstra, Dutch researcher in 2000, about 2000, early 2000. And they have identified three components. One is green water footprint, the other one is blue water footprint, and there's another component called gray water footprint. The first two are basically water lost from the system. Any production process, some production requires basically consume either rainfall, that is the green water footprint part, or the blue irrigation water, that is the blue water footprint part. At the same time, it basically reduce the quality of the water system, either by using, mainly by using fertilizer and other inputs. That part, somehow you can relate it to gray water footprints. But it is not lost from the system in a way, but it cannot be used for further activities without basically improving the quality. So it requires some water, again mixing that particular water with some good water, fresh water, and the amount required to mix to make that water quality deterioration into a better quality water is basically what is called the gray water footprints. But there are some issues here. Many people have issues on water footprints. It's not like carbon footprints or that you talk, because in most of the cases, water use has some local impacts. But carbon footprints it can have global impacts. So some people try to say, what we do in Thailand can have big impact somewhere else. It is not so. But there are other ways to link it through virtual water transfers and so on. But right now what I want to say is water footprints are defined, but when it comes to components, there are some major issues, unless you really use it in proper context. So without going into detail on those things, let me show you how we estimate these components. Well, water footprints we can talk about crop production. What you see here in the second section is water footprint of crops. It is basically the rainfall used, consumptive water used from rainfall, irrigation. That is what we call green water required, and irrigation, blue water requirement. These are basically direct water use. Whereas in the water footprint for milk, direct water use is only for drinking and servicing of animals. That's where people only think about that terms. Water required for milk production is only that. But it's only a very small amount of water requirement for milk production. And what we call indirect water use is the major part for milk in milk water footprints, or consumptive water use requirement for milk milk production. And it comes through soil moisture when you produce fodder and other feed. Soil moisture, that is mainly from rainfall, effective rainfall, and then you may provide irrigation for fodder and feed crops. That's the irrigation part, and then you basically pollute water in the local water systems through other inputs. That's the grey water footprints. So these are indirect water footprints, what we call, and there are some direct water. Direct water use is basically drinking and servicing. And even within indirect water use, there are two components. One is basically you can produce milk in particular area, that is the what you call the local consumption. At the same time, you can import feed from some other areas. That is the virtual water content in feed. So you can reduce your local water footprints by basically importing feed from some other areas. Or you can increase your local water footprints by simply using the all feed and fodder, or producing all feed and fodder in particular in that area. So there are different options for reducing consumptive water use or water footprints in milk production or in any other production, crop productions. Now, that's in a nutshell what are water footprints that we see every day in our different dialogues, different papers, and what are the components of milk water footprints, and why we really need to pay attention to water for milk. If you look at we have already seen that milk consumption is increasing very fast in India, South Asia. Overall in Asia, it's increasing much faster in the last two decades than earlier, before 80s. And also, if you look at Asia, production in terms of metric tons, 280 million metric tons in 2009, that's the total production. Out of that, South Asia contributes almost 64%, almost third of the production coming from South Asia. And in that, India and Pakistan contribute to the major part of the total production. That's the milk production. And important thing is, much of this milk production is coming from unsustainable water use areas. And if you look at the right side global picture, much of the Asia is having severe water stress. India, from Western Asia, Central Asia to South Asia, in some part of in China, in some part of other parts, in even Southeast Asia, are having severe water stress. Whether it is physical water scarcities, that is there's not enough water to develop anymore, or some economic water scarcities. So how do we, there are water stresses, and also these areas have high poverty, we have heard about it, and lot of livelihoods depend on milk production. And at the same time, if you look at India picture, lot of milk, some of the most productive areas, whether it is milk or even for crop production, are basically in the western and southern areas, and these are highly water scarce areas. And much of that thing is basically due to, and also unsustainable water use area, because there's high depletion of groundwater. So in that picture, the left side picture shows the groundwater depletion in India. And you can see much of the northwest are basically using much groundwater much more than what they have right now. So that's why we need to pay a lot of attention to water in the milk production pace. Because milk production, milk processing in factories, it takes only a small amount of water compared to the total water footprints. So we need to look at the water requirement for producing the feed, basically, to feed in the animals. And here's one example we did in Moga. And as you know, Moga is one of the major milk producing areas in India. That's in Punjab. And you can see its groundwater supply, groundwater levels have depleted almost 20 meters for the last decade. And it's almost 2 meters in some areas. And it's a major problem in Northwest. And much of the milk production in that area, uses a lot of feed, fodder, green fodder, and other feed from produced in that area, and also depends on dry fodder. That is basically wheat straw produced in that area. So a lot of milk production in this part of the country are based on unsustainable water use. And if you put those water amount in terms of producing rice, milk, wheat in this Moga district, and in fact rice, wheat is the major crop rotation in that area. Rice in the Kharif one season, wet season, and Rabi, milk, wheat is in the dry season, that is the Rabi season. And milk is basically produced in most households. You see milk production, whether it is in small scale or in large scale. And what you see here is groundwater. In the table, it shows you that in milk production, almost 94% of the total water supply, that is water lost from the system, is from groundwater. And wheat, it is 90%, and rice, it is 71%. And total water footprints for rice is about 1,800, and for milk is about 940 cubic meters per ton. That's about 940 liters for 1 liter of milk. And wheat, it is much less, about 554. In India, that's the case. You have seen some different numbers globally, but this is what we have estimated for Moga districts. And still, the major point I want to make here is substantial part of that water coming from groundwater. Consumed water is from groundwater. And also, it basically import a lot of feed from other areas. That also has substantial amount of groundwater, because right now it import feed from the nearby areas. Rajasthan, Gujarat, Madhya Pradesh, those are very close to the Punjab area. So there's a lot of virtual water import from nearby water scarce areas. And those are also major concern for milk production in India right now. And this is the way we estimated. We have looked at green fodder. What is the water requirement for green fodder? Dry fodder, that's basically, it is indirect water use. Dry fodder is basically wheat straw. If you don't use that dry fodder, then you have to use some other feed for the animals. And that requires some amount of water. And the indirect water is for dry fodder, or the virtual water content in dry fodder is about 184 cubic meters per ton, as much as the green fodder. And concentrate, that is internal water use, is 218. And in this particular area, external water use is about 300, even bigger than the internal water use. And drinking and bathing, it's only 15 cubic meters per ton. So this is the reason that it's very important. Water use for feed is very important in milk industry in India. And in fact, Prashant Kumar has already mentioned about this. And water is a key factor of sustainability of milk production in India. But there are ways that can, there are some ways that can overcome this unsustainable water use problem. But that may lie outside the milk sector. In Punjab, for instance, unless you address the water use in the rice sector, rice production, you can't address the unsustainable water use in that area. Consumptive water use in rice production itself is more than, at least even in some areas, close to the total groundwater availability in that area. So unless you address that question, it's a major question for the other crops also, crops as well as milk production. But if you can transfer the production patterns or reduce small amount of rice area and increase milk production in that area, then that can increase the income for the farmers, reduce groundwater depletion, and have overall production increase. Because rice can be grown some other areas also, not just in Punjab, because it's the groundwater is abundant. And these are some ways of slightly changing production pattern, production systems. You can address both questions, that is the increasing demand for milk as well as groundwater, unsustainable groundwater use. So this is what we have found in Moga, and it's more or less same everywhere in Punjab and in major milk producing areas in India also. And this is all India picture. What you see here is basically in many areas consumptive water use which depends on groundwater. More than 80% is much higher in northwest, that is in the left hand side. You can see the areas which depends on groundwater is much higher for milk production than the other water, that is canal water or even rainfall. And that also contribute to a lot of output in those areas. So unless you address this unsustainable water use in northwest, you have major issues in terms of milk production as well as the livelihood impacts in that area. So I will conclude with these three bullet points. One is, particularly in India, and I'm sure it is same with many other water-intensive, water-scarce countries in this region, we need to look at dairy-intensive production systems, especially if you have rice, wheat, milk, that kind of production systems, with less rice area. And it can have more financial as well as hydrological benefits, basically environmental benefits. Either it is milk and wheat and milk, or just milk only. Especially for smallholders, this could be a major option. And then import wheat from low consumptive water areas or basically high rainfall areas. And that is already happening in India. And we need to promote more of this kind of practices in these groundwater intensive areas, especially basically importing virtual water imports. And the other factor is basically we need to think about a change in herd structure. We have large number of indigenous cows producing milk. But these crossbred cows are basically producing 4 to 5 times more milk than the indigenous cows. Now, we seriously need to think about, how we want to change the herd structure and what are the feed requirements, where it comes from, and so on. These can be some of the things that are required to study more detail in India as well as in many other countries. And in fact, I hear even in Sri Lanka they are trying to introduce increased milk production. Unless you think about these factors, it's going again. We are going to have the same problem because people are just depending. Because you need water throughout the year. It's not just one season. So you need to depend on groundwater, and you need to look at exploitation of groundwater with respect to milk production in different areas, where it can be done, in which areas the feed will come from. And in fact, this particular picture in the right is basically coming, this one farmer basically having big, cattle, and it's a very small area. He has about, in this one I can't remember, but it's large hybrid cow, crossbred cows. And it's he has computers, basically, this is a very progressive farmer. And he has computers, recording daily operations and making a big profit. And it is an industry, it's a commercial operation for them. We can't do it everywhere, but at least we can make these smallholders also think like that. Incorporate that onto this corporate, milk production system, and I think it can be a major impact on sustainable milk production in Asia. Thank you.